Hello everyone, and welcome to Virginia International University's MBA 654 Accounting Information Systems course. During this first session, I thought it would be a good idea if we just talked a little about some foundational terms related to systems thinking. Because in this class we're talking about the accounting information systems, it's important to understand and have a little bit of background about what is that rooted in and what is a model or a way of thinking about this topic as we move through the class. And so when we look at a system and we think about it at a very high level, we can see that a system is made up of components, and it involves these components are within a boundary that we define. This boundary of these components interfaces with the environment. There are interrelationships between the components in this system. There are inputs into the system which may impact one or more components as a result of interfacing with the environment, and there are outputs. And so a way of thinking about an accounting information system is that each of these forms inside these boundaries, or this boundary, could be one form could be the payroll system, another form could be the accounts payable system, another could be the general ledger system, another the billing and invoicing system, or the fixed asset system. And so when we're talking about an accounting information systems, we can think about the multiple different components, and then I think we can better understand how when we, again in systems thinking, how these components interact with one another. And so obviously the accounts payable system feeds the general ledger system, the billing and invoicing system feeds the accounts receivable system, and both the accounts receivable and billing system feed the general ledger system. The payroll system feeds the general ledger system and may also interact with the job cost component system. And so you can see there are a lot of interactions between these different components of this system. Now, we can scale this also, and so we can think in more broader enterprise-wide zones and think of the system as the enterprise-wide system. And so these components then, one component becomes the accounting system, another component becomes the supply chain management system, another component becomes the human resource management system, and so on and so forth. So you can see how we can scale our thoughts about systems and how we think about systems. We can scale that to different levels within the enterprise. So it's a scalable concept. And so again, we want to look at from this diagram, and we want to keep in mind that there are 9 different components to a system, or 9 different terms when we're thinking about systems, one of which is a component. So we have 9 main characteristics: components, interrelationships, right, between the components, boundaries, so we have to have a boundary around our system that separates the system from the environment, a purpose, right, the system has to have a purpose, and in our case it's the accounting information system, the purpose being to gather, safeguard, store, and accumulate information for reporting purposes. There's an environment within which the system operates. There's input to the system, output from the system, there's interfaces between the environment and the system, and there are constraints. So we have those 9 main characteristics when we're thinking about a system. So we say that a system is a set of components that interact with one another and serve for a common purpose or goal. So we can have an abstract system, which is conceptual, right? And those are things like a social system or a cultural system. We can't touch or draw or photograph those. Or we can have physical systems, such as the human body is a system. Right? And so here again, we've listed what these 9 main characteristics are that we just looked at. So this presents for us again our initial diagram as just a reminder. And this defines these characteristics of components. So that's either an irreducible part or an aggregate of parts, also called a subsystem, They're interrelated, these components. That is, that the function of one is somehow tied to the function of others. The system has a boundary within which all of our components are contained, and it establishes the limits of the system. It also acts to separate it from other systems. All the components work together to achieve some overall purpose. So, what is the goal of that system? The system operates within an environment, and that environment is everything outside the system's boundary. The point at which the system meets its environment is called the interface. We have to face that every system has constraints in its functioning because of limits and resources. And we know that a system interacts with the environment through inputs and outputs, with an input being anything entering the system from the environment, and an output is anything leaving the system, crossing the boundary to the environment. So these are just the 9 components we talked about, and some language around how we would describe those. And so we also point out that the output of a system into the environment is often returned as input to the system in the form of feedback. And feedback is important because it helps the system monitor itself and establish some level of equilibrium or balance so that it continues to operate. And this figure just simply shows that we have inputs that come into the system that leave the system as outputs that result in monitoring that returns information into the system via inputs. And so this idea of control is what helps us to measure the performance of the system and whether it's meeting its goals, and helps us to tweak the system, the operating of the system, in order to better meet the goals. And we have control in the form of negative feedback, which is corrective feedback. So something's not operating correctly within the system, and through the form of negative feedback, we're able to reduce these performance fluctuations around their norm or standard. Or we have positive feedback, which really says the system is working, or portions or parts of the system are working as intended, and so that it can continue to perform in this manner. And so there are multiple different ways of to study a system and understand how it's functioning. And we have 4 items here. Decomposition, which is the process of breaking down a system into its smaller components. So we're just decomposing the system into smaller pieces so that we can understand how it functions. These components may themselves be systems or subsystems that can be broken down into their components as well. Then we have modularity, which is a direct result of decomposition, right? So if we decompose items, we're really breaking it up into modules, right? And so modules can represent a system simply, making it easier to redesign and rebuild. For instance, a portable CD player is a system, accepts CDs and settings of volumes and tone as inputs, and produces music as outputs. It includes the separate systems as its subsystems. One that reads digital signals from CDs, amplifies these signatures, and then turns the signals into sound waves and controls the volume of the sound. Coupling means that the subsystems are dependent on each other, but they should be as independent as possible. If one subsystem fails and other subsystems are highly dependent on it, the others will either fail themselves or have problems functioning. And then cohesion is the extent to which a subsystem performs a single function. In our CD player example, signal reading is a single function. So we have these 4 different ideas that help us to understand a way of studying a system. And then these are some systems thinking ways about perceiving. And you'll find that these concepts hold true in both in accounting information systems and how we're designing that, and in enterprise-wide systems, and how we may have some influence over that. But really, it's with respect to any system, we've got these system thinking concepts. And so that's to be able to identify something as a system. So when we think about a process or a procedure or a business function, then to think of that as a system. When we think of it as a system, we should then be able to identify the subsystems. By doing so, we should then be able to identify the system characteristics and functions and its boundaries. We should be able to understand the inputs and outputs to and from the system, and we should be able to identify relationships among subsystems. And once we've gotten to that point, then we're much more able to holistically solve problems or offer solutions. And so this idea of systems thinking will come in handy across multiple different functional areas in, I think, your business careers. And it's a very hot topic in academic circles, this idea of systems thinking. And so now we've talked about systems in general. Let's talk specifically about information systems, because that's really what we're talking about in this course, in accounting information systems. And so an information system is a collection of interrelated components that collect, process, store, and provide as output the information needed to complete a business task. And that's essentially what we're doing with an accounting information system. We're collecting the results of the processing of transactions, which result from inputs into the system. We're collecting that data, we're processing that data, we're storing, housing, safeguarding that data, and then the result of all of that is output in the form of financial reports, in the form of operating reports, in the form of any number of reports as needed by the stakeholders of the organization. So if we look at the example here, a payroll system, for example, collects information on employees and their work, processes and stores that information, and then produces payroll or paychecks and payroll reports for the organization. So that's a good example of the how we think about a component, right? A component of a system, the payroll system. And here, in a sense, we can think about the payroll system as the system in and of itself, or as a subsystem of the accounting system. And so again, we get back to when we think about it the way it's presented here, we can really scale the way we think about it from some detailed levels to some very large, high enterprise-wide levels. And so this just is intended to show the production system, and we can see that we have an inventory management system, we have a manufacturing system, we have a customer support system, which is comprised of a customer maintenance subsystem, an order entry subsystem, catalog maintenance subsystem, an order fulfillment subsystem. And so another way that we can consider or think of an information system is as a list of types of its components. And so here we're talking about a customer support system, and it's composed of inputs, it's composed of hardware, people, software, data, procedures, and outputs. And so you can see how, again, we've just taken a slightly different twist on the idea of what are the components within a system and been able to apply that thinking to this customer support function. So again, you can kind of see how we can really apply this systems thinking, and it becomes easier once we've applied, in a systems thinking mode, it becomes easier to try to wrap our hands around the problem, because then we have some tangible items that we can focus on. We have a boundary that will separate the system we're studying from the environment. We have inputs, we recognize interactions between components, so we're able to wrap our hands around those interactions and how, if we're problem solving, how those problems may be impacting the interface with the environment, how inputs from the environment may be creating those or adding to the problems, how those problems may be manifest in the outputs. And so there are a lot of different sort of practical applications of how we think about this when we have some sort of model like this to apply to it. And so here what we want to do is to just think about, in terms of a system, the differences between data, data flows, and processing logic. And so data is raw facts that describe people, objects, and events in an organization. And we'll talk about this a little later in our other lectures, but that data are discrete observations. They're really useless to the users of the information in that they really are just discrete, distinct observations. They don't really tell us much. That once that data is contextualized, it becomes information. And so when we talk about data in the form of an accounting system, we have debits and credits and general ledger account numbers and perhaps dates and periods of time. But that in and of itself doesn't tell us much. But once we reflect that data in a financial report or in a management or operating report, well, then it's contextualized and it becomes information and it becomes useful. Data flows are groups of data that move and flow through a system. So the data obviously flows through the system, and there are certain processing steps that transform the data into different forms depending on these trigger events. And so along with data flows, we think about this idea of processing logic that describes the steps that transform the data in events that trigger these steps. And so there are two approaches to information systems design. One is the process-oriented approach and one is the data-oriented approach. And the process-oriented approach is really based on what the system is supposed to do. So we're really indifferent to how the data is stored. It may be stored in more than one place, which is really not ideal, but the focus in the system design is what processes does the data support, not the data-oriented approach, which is a strategy that focuses on the ideal organization of data, which is independent of where and how data are used within the system. And this data-oriented approach is really when we think about databases and relational databases in particular, that's really the way most companies will design their information systems now, because it cuts down on a lot of data anomalies, which we'll talk about later. But just keep in mind we have this process-oriented approach that says, well, the information is going to be stored according to how processes are functioning and executed. And we have this data-oriented approach that really doesn't focus on the process at all. It focuses on the optimal storage and organization of the data itself. And so here we can see the two different examples where A is process-oriented approach, and here you can see that we have a payroll system and we have a project management system. The payroll system draws on tax data and personnel data. The project management system draws on personnel data and projects data. And so each of this data are stored in files, and we have the duplicate files related to personnel data. This is not ideal, obviously. We could have mismatches in the personnel data. So, the payroll system is accessing personnel data that is comprised of certain data, and the project management system is accessing that same information. And because of different issues with respect to updating that, they're not looking at the same data at the same time. Then we have beneath that in B, we have the data-oriented approach, and there you can see we have the same two payroll and project management systems, but they're accessing the same data. They just happen to be accessing data out of the personnel files that are in one file place. So this system is designed so that we optimize the storage of personnel data, and it only exists in one file within the system and not in multiple files, as was the case in example A. And so figure 1.9 here just really gives us the key differences between process-oriented and data-oriented approaches. And I point you out again to the fact that under that state of the data, where we have under the process-oriented much uncontrolled duplication, and that was our personnel data that we just looked at, right? For process orientation versus a data orientation that has limited duplication, and if there is duplication, it's controlled duplication. So you might just want to make yourself aware of these different differences, or these key differences between the process versus data-oriented approaches to information system design. And so that then gets us to this accounting cycle. So we talked about systems in general. We talked about information systems, and because we're in an accounting course, we're talking about accounting information systems. And so that accounting information system is really geared toward helping facilitate the completion of this accounting cycle. And I'm sure that this is not the first time many of you have seen this, particularly those of you who have a strong accounting background. But, so the accounting cycle includes journal entries. It includes general ledger accounts that result in an unadjusted trial balance, and then when we go to close the books, we have adjusting entries, which get us to an adjusted trial balance, which result in financial statements, which then cause us to have to book closing entries, whether that's monthly, quarterly, or annually. We get to a post-closing trial balance, and then we start our cycle again with journal entries as a result of having processed multiple transactions. And so the accounting information systems is really designed to facilitate the completion of this accounting cycle. And so with that, I think we're ready to move on. Now, this information that we talked about here is not presented in the text. I hope that it's a little bit of help in creating a mindset and getting some sort of very high level preliminary understanding of systems thinking, information systems thinking in particular, and then how we translate that into the role for an accounting information systems. And we'll continue to come back to some of these concepts throughout the semester, but I hope this has helped to set the table for what we're going to start talking about very shortly through the rest of the course. So I appreciate your time. I'm looking forward to this semester and to spending time covering these topics with you. And thank you.